Right, well I'll start again, and because I'll spout it to myself and there's no memory card in the solid state video recorder. So we're doing this Academy CB502, which somebody really kindly sent us, and they often don't have the serial number plates. It's not because they've been stolen, because it's just a stick-on label. In fact, they rarely have that one. So it's a GT868 from the great Taiwan Emporium, and there's a good reason why we're doing this, apart from the fact I like great sets, even though they're pretty poor on receive. As far as selectivity goes, they work alright out here because there's no other users. But we're doing two videos at once. I don't know which ones you're going to see first. I'm working on a Merit base station adapter. So back in the day, in 1981, there was about 3 different base station adapters that could be bought, and these were a box the size of a base station radio of the time, let's say approximately 19 inches wide, and it would swallow up a mobile set, and having a built-in power supply, sometimes an SWR meter, sometimes a forward-facing speaker, and turned a mobile set into a base station at a more convenient angle. Some of them, the radio was such that the speaker in the bottom came out through the front, so it didn't use a separate speaker. Now, one of the rules of one of the UK rules is you can't keep an SWR meter in permanent place. Obviously, you use it to set up your aerial, and you check it from time to time. So, not ideal to be having a built-in SWR meter on these things. The reason being that the diodes in SWR meters can and do emit spurious emissions. And the other thing is you've got an insertion loss with an SWR meter, so you're never going to get the same range on transmit or receive if you've got an SWR meter in line. We're not talking about the 1 or 2 sets that have built-in SWR meters. Even at the time, the Fidelity 3000, another great product, great from Taiwan, not great as in fantastic. That had a built-in SWR meter, so presumably built-in SWR meters were an okay item. But I'm not sure. Yeah, it's a bit of a grey area. So Mark's already tested this. It doesn't work. You've got no transmit or receive. So we're going to start by looking at this. So I don't know which video is going to get launched first. The base station adapter. We've got 2 of these, and I've pulled out the one which was handy, and the innards isn't the innards which would have been original. So kind of disappointing, because I don't know what was inside it. And I'm going to give you a spoiler alert. The power supply inside the adapter box has been taken from a Harvard H404 H407 base station. Who in their right mind smashes up a proper good performing base station to nick the power supply out of it to stick in a $39.99 base station adapter? There we go. Anyway, it's having a full overhaul. We'd better open this up because Mark says it doesn't work. And I might be starting this video and there may be no hope of getting it to work. You know what, we're going to end up with all the screws out, aren't we? We really are. So I had no idea that those base station the Merit ones were actually great. But it goes on, when you think about it, that 6-channel chunky handheld is a great, and which they did. I think there's a Merit mobile, but that's not a great. That's a Falcon FCB 1281 rebadged, or Banatone Beam Breaker, or Compact 40. But when the loudspeaker inside says great, and it's got Great's favourite typeface, well, great it is. Okay, so very quick inspection. I mean, that doesn't look messed with in any way. One of the things that can happen with these is the 8-volt regulator can go down. It's not even got the screen plate missing. It's had some smouldering around there, hasn't it? Tell you what, we'll keep that off. I'll just put some of the more powerful glasses on. One of the things that can fail in it, well, it's two things. One is the coil L6 just there. If you use the screws that were provided in the original box and you screw the long one into there to mount it, then it pushes over that can and breaks it. So that's one thing that can happen. It's not happened to this. And the other thing that can happen is that resistor 65 just there, if you've had a bad SWR or no aerial or something, you can end up that being burnt out, and that's usually power output of less than 1 watt. So the normal power output of these is between 1.7 and 3.5 watts. They're not a 4 watt radio, and well, I have seen 4 watts on one, but I mean, I've done this 40 years, I've seen one. We're going to put a fuse holder in this, and there goes the door. Okay, that was delivery of stuff from RS Components, and I'm glad about that because one of the items is for that Merit base station adapter. It's got a 2-core mains lead on it as presented, and it really needs a 3-core mains lead, so I needed to change the cable grommet. I'll tell you something else I've added, and that's a fuse holder because there's no fuse on the primary side of the thing. Right, so now put the mic on, power supply. Let's connect it up to our famously short-circuiting crocodile clips, which is all part of the fun. Power supply on 13.8 volts. It's powered up, it's on channel 37. Let's connect it up to the test gear. Connect it up to the public address speaker. We'll connect it up to the extension speaker. 10 decibels off, which is where we want it. So we'll start with PA, which we're in.
Testing 1 2, testing 1 2. Testing 1 2.
Now these are always full volume. You have no volume control over the public address. So if you bought one of those dreadful power mics with a little wheel on it for volume, well then you'd have adjustable volume. I'm actually too hot in here. I've got shorts on, I've got a t-shirt. I think we're going to an athletic vest. I don't think we'll be quite going down to speedos. Got air conditioning on, but it's just too hot. Well, it's too hot for me. Right. So we've done that. Right, it's going to transmit. Let's put picture in picture on so you can see what I can see. And as Mark says, we've got nothing happening. So if I look at my ammeter on the power supply, we're currently drawing 210 milliamps. If I key up, we're drawing 212 milliamps. So nothing's happening, is it? So let's have a look on receive. I'll put 2779125 into the signal generator. Looks to me like the synthesizer's not running, to be honest. Very, very rare on these for that to fail. Well, I've got a signal generator on full whack, and we're receiving nothing. Just to prove to you, we've got the signal generator on full whack. We'll put our walkie-talkie on, which today is the Joe Pix one. And if I override this, I'm sure that we've got so much signal, I can put it on full whack. Where's squelch override? Yeah, there. So you can hear the signal generator just through the aerial. So we've got absolutely nothing. RF gains at full. Just in case the switch is playing up. Right, so next thing we'll do is I'll just pop the signal generator off. And we'll go back to the walkie-talkie. I'm going to key up with the squelch overridden. I am going to find it. Well, look at that. Hello, testing 1, 2. So synthesizer is running. How's that for a good test? Yet we've got no transmit and no receive. Well, that does get interesting. Now, I don't think there's going to be two separate faults. You know what, this is in very good condition, isn't it? So look at the front of that. I don't think this would work for donkey's ears. You know, a lot of those sets in boxes on eBay, you know, do you remember I was very, very, very kindly given a G-Col GTX680 in a box? Just to remind you, it's here. One of our customers and viewers very, very kindly gave me one of these, which he'd bought it in a batch. But you know, they're all returns. So you end up with these frustrated sales from 40 years ago in warehouses. And you know, so you look on eBay and brand new in box. Well, yeah. I went to Ace Audio in Nottingham, who were doing audio line CB sets at the time, and this was 1983. And I says, have you got any returns on your Uniden 100 and 200 CB radios? You know, I buy returns. So he got the manager to take me to the cellar, and there were two piles of radios with about 100 sets in each, and one pile was the returns and one pile was the ones to go out on the shelf for sale. And you know, Uniden 100s, reliable sets. But there you go. Well, until the capacitor started failing and we've got to change them. But you know, it's only a like £1.50 job, isn't it? But I suppose it's the labour side of that. Why can't I open this? Wow, finally got that off. Well, I'll have a look at the circuit diagram, but chances are that IC is going to be faulty. So we've got to take the shield plate off the bottom. Well, that is a short. I've just removed a short. between there and there. So that's been there forever, hasn't it? Let's power it back up. What? Blow me. Now, we still haven't got good transmit, but it might have been fiddled with. Just have a quick fiddle with the tuning. Just put our walkie-talkie on, we might hear it transmitting. Okay, so it's still not transmitting apart from a few inches. Right, well that's made a start. Let's just check it's not a dry joint. Nope. So when that shield plate was put on, it generated a short circuit between there and there. That's probably never worked since new. Right, I'll be back in about 2 hours. Right, so we need to look at the face lock loop to make sure it's not inhibiting transmit. So you get the, it says using an oscilloscope, I'm using an electronic voltmeter, so it should have the same effect. And on pin 8 we should have got logic high on receive, and when we go into transmit we should have logic high. So pin 8 is the one with the handy test point. You'll see we have logic high because it's 7 volts. So we're going to transmit, we've got logic high, so inhibit is not the issue. So select channel 20. That's it. That sounded a bit freaking and not stirred, didn't it? Had we not got logic high, it'd be CT202. CT202 is that one, whereas the frequency set one is there. So may not have a problem in the VCO department now. Tell you what, that capacitor is hot and has been hot. Now that's not right. So you know what? Because that's an obvious problem, we'll do that straight away. I haven't got the layout, so I can't say what that is. Let's get it unsoldered. Okay folks, well I eventually found it, and we'll take it out. I mean, the fact is it's heat shrink has shrunk, which is usually indicative of it usually being too much volts, but this is 50 volt rated, so it can't be too many volts. So I've gone to Mr. Chippy's bench, we've got the ESR meter, and we'll see what it reads on here. It says it's fine. Let's compare that with a brand new one. It says it's fine, but even more so. Right, so we're going to put the new one in anyway, because when you look at where this is, because now we've taken it out, we can see it's capacitor 56. When we actually look at the circuit diagram as to where capacitor 56 is, so on the Fidelity circuit, which we'll call it the Fidelity, the great GT8 58868, the phase lock loop section is here, and we were monitoring pin 8. Pin 8 is J on here, which is where this inhibit circuit lies. The very first thing after in the inhibit circuit is capacitor 56. So if that goes short circuit between there and deck, same as inhibit, isn't it? And it was getting warm. Right, we'll put the other glasses on. Normally use those expensive Nikons, but they're not on this bench, not in this building today. But I've only got 6 inches of solder as well. It's because I'm doing the power supply as well, so I'm doing 2 jobs at once, so things end up on other benches. Let's do that while we're at it. So theoretically the part I've taken out works, but there's no logic because it doesn't. It's getting hot. What I'm going to just do is tune for maximum current consumption rather than with the walkie-talkie. I've got 198 milliamps. And the fact is it's had a short circuit on it, hasn't it? So it's going to easily cause some snags. Transistor could be shorted out. Let's get walkie-talkie back. Seems to be moving further down the stage than it was before. I think it's time to get the RF probe on it. That capacitor's not getting hot. Right, big Russian RF probe. Let's put it on quite a big scale. And we'll look at the driver. There's another great big solder splodge. This time, of course, it's not under where the shield plate would have been. Any more while I'm kind of looking there. I mean, that one under the shield plate, it's a bit of crimped, chopped off wire which is not being brushed away during assembly, and then it's gone and got stuck under the shield plate. It's a manufacturing defect. Anyway, let's have a look at this transmitter. A dry joint. I don't think it's going to make any difference to this, but it could in the future. These aren't sets that normally suffer from dry joints. Okay, so having cleaned the printed circuit board with the isopropyl alcohol around the transmitter drive area, we now have transmit. So something must have been shunting to ground through just crap and crud, and that's why we cleaned the boards. Right, we'll go through transmitter alignment. Turn my walkie-talkie off, I'll be getting feedback. So I tuned it for maximum signal on the walkie-talkie in the hope of getting something coming out of the spout, and we'll now start and do it properly. So we're on the 4 watt scale, we're on the 3 watt scale. I'll start again. So no TX, no RX, and that was short circuit on PCB under VCO screen plate, and we got 1 microfarad capacitor, C56, plus clean PCB. So it's difficult to put a before and after, because if it's going to have been messed with the tuning. We'll do a receive one. These have never been touched, so we'll take the before readings after I've tuned up these stages. So right at the moment we are doing about 400 milliwatts. Just check we're on low on high power, which we are. So 400 milliwatts. .3 watts. Good thing about this, it's not going to have had any use. It's been sat there slumbering all these years. There you go. So we've got 2.9 watts on channel 20. Channel 1, got 3, channel 40, 2.8. Go back to channel 20, on low power we have got 320 milliwatts. Back on full power, current consumption 685 milliamps. Deviation, for what it's worth on this test set, Wallow is over the top at 4.5. So let's look at the frequency. The test gear's been on for hours. 2779146 needs to come down. Do that right away, and then we won't have to do the receive on a different reset it for receive. There we go. So it's playing that 127, and it's got room to manoeuvre when it comes, because it dropped with age. 2779 127. We'll set the signal generator to that. 2779 127. There we go. So the meter lamp is working, PA is working, the potentiometers are working, the sockets are working, the switches are working, because only one is PA. So let's have a look at some of these other parameters. What does the meter say on transmit? And it says 3.5. And on receive, let's put the test equipment back in so we can hear what it's doing. I did finish the power supply thing I was telling you about. That should be uploading. So that's going to you'll have seen that first, the Merit CB700 power supply. And notice how it fits in with the model numbering. This is the CB701, sorry, this is the 702, the one with the two knobs is the 701. So the power supply adapter is 700, 701 for the smaller model, 702 for this bigger model. All fits in with their numbering system. And we'll do the on-the-air test with this. Instead of it being on my bench power supply, we'll do it with it being in the CB700 base station adapter box. I won't be running it through the SWR meter because of the insertion loss of SWR meters, etc. Right, so if we switch over to the Synad meter, and let's hope that the receiver's never been fiddled with. Let's make sure we've got RF gain up. Yeah, it's working great. No pun intended, because it's a great set. Wow. 12 dB, we've got 0.41. For 10 dB, 0.34. A lot of new sets won't do this even before, but then hopefully they've got better selectivity than this. 0.92. Squelch. It's an AM squelch, and this is a special separate detector for AM just to do the squelch. Makes it soft and gentle. Right, let's have a look. I've got it. Let's put the attenuator up on the inset picture. So 1 microvolt, 3 microvolts, 10 microvolts, 30 microvolts. It is exactly 30 microvolts. It's a bit wishy-washy, that. Seen worse, but it's a bit wishy-washy. 30 microvolts. And let's look at the sensitivity of squelch. So threshold. Signal generator parked at 0.3. Signal generator back on. 1.4. So again, that's not as good as it ought to be. But that should be sorted out with the preset. And then finally, let's just look at S9. So I'll put S9 on the signal generator, and we should have S9 on the meter, and we haven't. So let's see where that is. S9 is there, and it is 21, like my age, microvolts. That's far too sensitive. Very, very generous. So it certainly had these wiggles, but the actual receiver alignment, I don't think it has. I'll tell you what we're going to do first before going further into this, and that is put the screen plate back on. And I'm going to put the bottom on underneath because of the capacitive effect. We will also need to solder the other screen plate back on underneath the VCO. I'm tempted to. Look there, there's enough there to twist back. Ideal if we pop a bit of solder, because that can be microphonic in a mobile situation, going over bumps. You can end up transmitting that clicking. Whether or not we've got enough solder. There we go. Let's put this back underneath. This time without bits of wires trapped underneath. And if the set still works after that, way, yeah. Right, here goes our tune-up. So are we still on frequency? Yes, we are. Glad about that, because I don't want to take that cover off and on and on and off. Right, here goes. So we've done it up to there. We've got that and that. That is not to be touched. That's the third harmonic or second harmonic trap. So we don't adjust that except with a spectrum analyzer, which is pointless putting on because it's not being fiddled with. There shouldn't be a core in that one. This can vary depending on the production run of the set. This is a later version. So just 2 cores to adjust then. Just to do that. We'll go on to the 30 watt scale on the test set because we're now doing 3 watts. Just a word of warning, somebody did say something about soldering irons and getting the wax out. You know, for these polythene cores like this, you can't be using a soldering iron with them because you melt the coil. This is a Paxilin type of material, so that's okay. So just be aware, yes, not every core that's got wax in it can be done with a soldering iron, and you can end up having to use earwax thinners or a hairdryer very, very carefully. We do use a hairdryer. Not that any of us have any hair. Oh, Mr. Chippy's got some hair, but I don't think he uses a hairdryer. It's not a thing, is it? You know, even when I had hair, you know, you'd have a bath, wash your hair, and you've got to go out. You get dressed, you go out. Your hair dries, doesn't it? You don't need to. My late mother would have said, "You get your death of cold," which was stupid coming from somebody who was a nursing professional. We want the kit of trimmers. Is it the blue one on these, or is it the green one? It's the blue one. There we go, 3.4. And that's it. Now it's possible that these airspace ones can be in the wrong position. I'll just very carefully check. Yeah, I've got 3.6. Just go back on that. .6. Okay, let's look at the other channels. I want it to be within 0.1, 3.5 for channel 40, channel 1, 3.5. Well, not that good, haven't I? 3.5 watts, 3.6 watts, 3.5 watts. So, go back to channel 20. And we're now drawing 823 milliamps, and our low power, go back on the low scale, has dropped to 200 milliwatts. Good. So it's a 3.5 watt set, it's doing 3.5 watts. And of course, before people go, oh, is that all it's doing? Remember, a lot of the new sets are 2.7 as they come out of the box, and a lot of the new sets we can't get beyond 3.4. Remember, this is a commercial test meter, and if it was put on a hobby meter like a Zitagi, this radio is probably doing 6 good buddy watts. And it sounds awful, that, but it's the way it is. It's the way. I've even had, there was a radio amateur talking on our repeater, and he's bought a new Yaesu radio, which is supposed to be 50 watts output, and he says it's doing 30. So he sent it back to the supplier, and they say it's doing 60. Well, it isn't. And I tell you what, I bet it actually is capable of 45. But it depends where you're going to be in the band. So it's going to be different on different frequencies. So this is shops telling you BS. I believe him, but he's not going to do anything about it, because it will be a 45 watt maximum. That's because American business radios are 45 watts, so they're going to be using the same components. Right, so we've done the transmitter. We want, when we key it up, to say, back to full power, I want it to say 4 watts on the meter, which it does. It's absolutely bang on the 4 watts, so I don't need to adjust it. But if I did, it's the preset just there. That's the dull looking thing, and it's dull because it's silver plated and it's tarnished over. We'll do deviation on the other test set. Actually, I'll do it on here, and then we'll come back to it. Wow, that should be a peak of 2.5. I'll tell you what, we'll do it right now. I've sometimes forgotten to double check and go out on the air test, and Mr. Chip is going, is that over deviating, or oh, is that too quiet? Let's put that away before we lose it. Change his glasses so I can see the test set behind me. One, it's a bit quiet. One, that's it. They've always got very good audio on these. So chances are it was only slightly above where it should have been. The Marconi test set I'm using needs the capacitors changing in the deviation meter, and sometimes it's right and sometimes it's wrong. But seeing as we've got 3 of these Marconi test sets, and we've got the one behind, and we've got a Schlumberger one, and so on, so I'm not bothered, because we've got other machines. Right, so I think it was probably 3.5. So we'll now put it 2.2 to 2.5, which it is. That's reading 4, that's correct. Okay. Receiver. So I'll put S9 up, and we'll put the oscilloscope on, and we'll actually put it on the inset picture. Looking to do the detector. Weird detector in these sets, and I've shown you the method. The method in the service manual is using a sweep generator. It's very long-winded, and that's because they weren't expecting to use cyanide meters back in 1981, so it's quicker. That was absolutely spot on. Just need to check it with the pink one as well. Absolutely spot on. Right, well, so that needed nothing touching. Can't speak. Here we go over to the cyanide meter. We're at 0.3 of a microvolt. We're about at 4 dB. I might have to just pop it up a bit, see whether we get anything more out of the receiver, but it was already working well. We have got more. Now, I don't think that's because it's been fiddled with. It's more likely because it was not as meticulously aligned in the first place. at the factory, they've only got to adjust it to a line and it carries on the conveyor belt. They don't go backwards and forwards till they've got perfection. Well, we have got that a little bit more. Let's go over to the others. I'm going to put a bigger signal on. That was already spot on. That was already spot on. That was already spot on. Then we go back to that pink one. And that it was spot on. Right. Let's get a new reading then. 0.48, which is worse. For 10 dB. 0.44 and
20, turn the volume down.
0.78. So what's happening here is we've sorted out the detector so everything sounds great and not garbled, but we've lost sensitivity. It really doesn't matter. Right, we need to do the S meter. So I've got S9 on the signal generator, it's supposed to read 9 on the meter. So there. And now we need to do the squelch. Squelch to full. And I want it to open at 100 microvolts, which it now does. So that's 100 microvolts, and that is exactly where it should be. Let's see where the sensitivity of the squelch now is. So with the set, the test set is now on standby, parked at 0.3 of a microvolt. The radio, that is the squelch position. Switch the signal generator back on. 0.85 microvolts, that's more like it. There we go, we're done. So does the speaker work? Yeah, I mean, when this was assembled, that piece of wire would be under the VCO can, and I would think, I mean, it's going to have worked coming out of the factory, but by the time it's been shoved in a container and come thousands of miles from Taiwan, I bet it's worked its way into the works. How about that? And I doubt this worked. I don't know what that capacitor was getting hot for, but it tested alright on the tester, but it wasn't alright. Right, we'll unplug the extension speaker. Yep, that works. So next time you see this, it'll be on the air test, and it'll be shoved in the 700 CB700 base station adapter box. I've made sure the power supply is correctly set so that it doesn't spoil our continuity of on the air tests. There were 2 screws missing on this, so I'll have to worry about that another time, like tomorrow morning. I was going to do a realistic 2003 until I started doing this Merit base station adapter, and I thought, well, if I do a great set then it'll all fit in nicely. But I was going to do a realistic, I can't speak, 2003, which was the one-hander. And as you know, I'm dead against modifications, but if you don't modify the handset on those, they sound muffled and woolly. So we're going to be modifying the handset. I'm going to do because I've got 2 of the sets kicking around on the shelf, we're going to do one with the modification, and then when I do the on the air test, we'll do the demonstration. When we get to the 5 mile point, I'll swap mics, and then you'll be able to hear the difference. I even went to the trouble and expense of ordering a service manual from the United States to look at the American AM equivalent model to see, whether there was a difference. And if I remember rightly, there was no difference at all. It tells me that they effectively put the same handset on an FM set. Well, back in the days of Pi business radios, they had different microphones which tailored the speech differently as to whether you're on AM or FM. So it does make a difference. And you'd think that the manufacturer like GRE, General Research Electronics in Japan, wouldn't have made a boo-boo like that, especially on a set that was $149.99 at full whack, or $139.99 when on offer. But there you go, it happened. That doesn't look like. That's a self-tapper. So the fact we've got a screw missing, we'll address it at another point. Right, we'll take the aerial out. We'll see whether there's any good or bad buddies out there. Switch the test gear off. Learn some new swear words from Nottingham. One on a Roger. You get a dimmer. Absolutely nothing. Mind you, it's 6 o'clock, they're being called in for their tea by their mummies. Right, I'm not going to use that. Yeah, we'll put it in the base station adapter. Thank you for watching the Academy CB502. Or is it a 702? It's 702, isn't it? From 1981, using the great GT868 chassis. And thank you to the person who sent it in as a gift.